Yeah, good afternoon, everybody. My name is Paul Wainwright. I'm with the Department for Environment and Water. Today here to talk about a project which involves a series of low-flow trials in the Mount Lofty Ranges. This is a collaborative project funded by the Adelaide and Mount Lofty Ranges NRM Board, as well as the South Australian Murray-Darling Basin NRM Board. So today I'd like to talk about what low flows are. I'd like to explain why there's a focus on low flows and why that's important to the department in both a policy sense as well as a technical sense. I'd like to show you a couple of case studies from our trials, talk a little bit about some of the monitoring that's happening at the trials, and also discuss a little bit about some of the learnings that we've made over the past couple of years from the trials. I thought the logical place to begin today was really just to clarify what low flows are, because that's very often the question that we're asked when we go to speak to landholders is sort of, what do you mean by these low flows? And the important thing is that they're part of a natural flow pattern. You can imagine in these ephemeral systems that we have in the Mount Lofty Ranges, throughout the calendar year we have times of the year when catchments are very dry and we might have fairly limited rainfall that creates small flow events. But there are also times of the year when the catchment is saturated and we have higher rainfall events creating high flow events. What we're focusing on here, though, are those lower volume flows that develop in catchments. And we characterise those as flows below a certain threshold, but that threshold depends where you are in a catchment. And so we use a term regularly called a threshold flow rate. So for every dam in the Mount Lofty Ranges, there is almost a unique threshold flow rate, and that represents a fairly small percentage of the total flow. It's in the order of 10 to 15% of the flow which develops in a catchment each year. The important thing about these low flows is that they provide us with very large environmental benefits, and I'll talk about that a little more in a minute. So why the focus on low flows? Well, as you heard in the previous talk, the low flow part of the flow regime is ecologically really important in ephemeral systems. You can imagine, and perhaps right at this moment, it's a really interesting time in the year because we've had 3 months where we've had really limited rainfall in the Mount Lofty Ranges. If we can provide low flows in and around infrastructure, we're able to provide these provisioning flows which are able to improve the resilience of these systems. These flows help us to maintain refuges for fish, or they help us maintain the frequency or rather the extent of some of the riparian vegetation. It's these flows which just enable these environments to sustain themselves through those dry times that that provides the resilience that they need. So the issue is that these low flows are heavily impacted by water resource development, and there's more than 20,000 dams in the Mount Lofty Ranges. So what we're having to do is think very carefully about the policy context. How can we ensure that we can, or how can we effectively implement a policy to provide low flows to these water-dependent ecosystems without adversely affecting the production of many of the enterprises in the Mount Lofty Ranges? So the provision of low flows is really important in terms of the way that we can provide water in a planning context as well. So because low flows are very important to ecosystems, they really are the primary mechanism in our water allocation planning processes to provide water to the environment. And we just need to remember that what we're trying to do is find this balance between economic, social and environmental water provision. And the focus here is very much on how we provide that environmental water. So what we did, recognising the policy need, was we thought, well, let's set up a series of low flow trial sites to help demonstrate how we could practically pass low flows. So back in 2015, we began the process of establishing 11 sites, and these are They were selected using a range of criteria to work with the variability that we see in catchments across the Mount Lofty Ranges. We intentionally put them or located these sites at dams which were tricky to manage, dams of varying sizes, in both sort of drier catchment and wetter catchments. And the intention was to sort of see how we could effectively manage low flows. So these sites are used as well as obviously being important monitoring sites and testing the concept of designing an effective low flow device. They're also used as part of our community engagement as demonstration sites, and they're all fitted with telemetered monitoring to help us validate our modelled data. One of the things that we've learnt is that the community don't respond very well to modelled information. They want us to go out and collect real information that they can understand more easily. So the trial sites have been helping to achieve that objective as well. Here's just a map of the trial sites. They are located in... We've got 11 spread across the Mount Lofty Ranges. The 3 in the northern area are in the Marne-Saunders catchment, and then we have a number spread through the eastern and western Mount Lofty Ranges, representing the sort of range of catchments and climatic scenarios that we experience. So with our monitoring questions, there are a number of objectives we have, but there are 2 fundamental questions that we wanted to try and answer. The first one really is the low flow device doing what it's supposed to do? You know, is it passing the correct amount of water? And how can we measure that and then use that in a positive sense to help with our communications back to the landholder? So what we do is we monitor all of the inflow into the dam, and we also measure the amount of water that's being passed through the low flow device. The other question we've got, we regularly receive from landholders, is that they're very focused on trying to understand what effect it may have on their water security. So if they've only got one dam and they're required to pass low flows, what effect will that have on their ability to keep carrying out their business? So one of the things we do is monitor the change in storage in the dam, and that helps them to compare a scenario where they might be providing low flows compared with one where they don't, and they can understand whether or not the 10 or so % of flow that they're passing through the low flow device is something that they can live with, and therefore maintain their business, but at the same time provide those required environmental flows as well. So here's a fairly typical dam in the Mount Lofty Ranges. This is just a small little 1 megalitre stock, what we call stock and domestic dam. So what we're doing in this particular case is we're measuring the inflows coming into the dam. We're measuring, and it's a bit hard to see the low flow device on this dam. It's just a little bit over the ridge line at the back of the dam there, but we're measuring the volume of low flow that's passed back into the environment below the dam, and we're also measuring our effect on the water balance in the dam. So when we talk about low flow devices, I just wanted to discuss briefly, there are 2 sort of broad schools of devices, if you like. There are those that bypass the water before it gets to the dam, and they pass water generally in a pipe around the dam and back down into the environment below the dam. And there is a more complex group of devices that we call release-style devices, and the idea here is that the inflow is allowed to flow into the dam, and then we calculate how much of that volume is low flow, and then we either pump it or siphon it from the dam back to the environment below. So looking at a couple of case studies quickly, the first one here is that one we've got located at Back Valley in the western Mount Lofty Ranges. This is in a fairly wet catchment where there's a lot of base flow or spring activity. We've got a beef cattle property here, and a dam. The dam that we're treating is around about 40 megalitres in size. Low flow devices typically consist of 2 parts. There's generally something which is located upstream of the dam, and then there's some infrastructure which is located normally at the base of the dam wall. So in this case, we've got the photo that you can see on the right-hand side there is a small weir which measures all of the flow going across that plate. And that then sends a radio signal to this little device that you can see on the left there. That's a valve that's placed on a pipe that's in the dam wall, and that opens up in response to a radio signal and lets the low flow through back into the watercourse below the dam. So we've been collecting some preliminary data from this site. At this point in time, we've only sort of got a short data series, so February 2016 to June 2017, and during that time there was 42 megalitres of flow that moved into the dam, and around about 18% of it was passed as low flow. So that's a fairly high percentage, and the reason for that is that there are springs upstream of this dam, and those springs discharge at a fairly low rate, which is below the threshold flow rate. So the percentage we see here is sort of typically higher than what we're finding at most of our other sites. Another example here, this one I'll run through quickly. This is in Bugle Ranges. This is a dairy property with a 40 megalitre dam. In this situation, we've got a bypass type device. We've got a weir located upstream of the dam, and we have a bypass pipe that's buried that takes the flow around the back of the dam. This is just a close-up here of what the weir looks like, and this is a device that separates the low flows from all of the other flow, which is able to flow straight across the weir and into the dam. This particular site, for the similar period in time, this one shows us that around about 10% of the flow was expressed as low flow. So this is very much about learning by doing. Some of the challenges, well, we've been working with privately owned infrastructure, and of course sometimes there are unexpected things from doing that, often challenges with either the condition of infrastructure or the way it's maintained. We often have to work with challenging flow conditions, and during this period we've actually had some high flows, which has tested the integrity of some of our low flow devices. Obviously we have to work with a range of in-stream conditions, and we've had sites which have sunk in peat, and we've had sites which we've had to use rock breaking equipment to install because of rock. And there are other environmental factors which have caused us problems along the way. It seems that yabbies kind of like our pipe work and our water meters quite a lot, and some of the devices providing habitat for snakes and various other sort of debris that falls. So just in summary, I think it's important that to recognise that this is really an innovative project. There's no one else really trying to achieve this at this sort of scale. And really the trials came about because of that requirement to sort of test proof of concept, but also that we are now embarking on projects which involve the broader implementation of low flows. So these trials have been very informative in helping us to refine some of our low flow devices and in helping us make some fairly important decisions. What we continue to do is document the learnings from these trials, and we've got a hunger to obviously develop a longer data series to prove up some of this monitoring data, because what we've got thus far is based on a fairly wet period in time. So data is publicly available on the website that's listed there, and if you'd like to contact me, please do so on the email listed there. Thank you.